Welcome, everyone. I'm David.
And I'm Sophia.
Welcome, everyone, to TechDaily.ai. You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, contact info@techdaily.ai to get started today.
So today we are strapping in.
We really are.
Yeah.
The AI arms race is just moving at an incredible velocity. If you blink, you might actually miss an entire generation of models.
It's unbelievable. And for anyone trying to build a business on this, understanding the real differentiators it's everything.
Exactly. We're going to try and cut through the marketing noise and look at three key areas. First, the big proprietary battle for performance. Then the huge architectural shifts happening behind the scenes, especially around efficiency.
And finally, the big strategic question. Specialist versus generalist AI agents?
So let's start at the top tier, the proprietary battle. It feels like OpenAI, Google, and Anthropic are in a perpetual sprint.
They are.
When we talk about actual real-world usefulness, especially for something like coding, who's really leading the pack right now?
Well, the data right now suggests the champion for real-world software tasks is Anthropic's Claude Sonnet 4.5.
Okay.
And this isn't about passing, some abstract test. This model is built for what they call long horizon reliability.
Let's unpack that. It tops the SWE bench.
Yeah.
Why is that benchmark so important? What makes it the gold standard?
It's the gold standard because it's a live repository level benchmark. In simple terms, it's not a simulation. It autonomously fixes actual bugs from real-world code bases.
So it's not a toy problem.
Not at all. And Claude Sonnet 4.5 is at the top with a 44.5% resolved rate.
Wow. Resolving almost half of real-world bugs on its own. That's a massive step towards AI agents actually being useful in a dev cycle.
Exactly. That long horizon reliability is key. It means the model can handle tasks that might take thousands of steps, over hours or days. It's built for sustained effort.
And they're pretty open with the pricing too, right?
Yep.
Super transparent. About $3 per $1 million input tokens and $15 for output.
Okay, so how does let's call it the established heavyweight, OpenAI's GPT-5, stack up against that?
It's right on its heels. GPT-5 is just behind on that same SWE rebench at 41.2% resolved.
Still very impressive.
It is.
Yeah.
And while it might give up a little ground on pure coding reliability to Claude, GPT-5 has this massive edge in its ecosystem and, crucially, its context size.
The context window, 400K tokens.
Right. And that is the real differentiator for a lot of enterprise users.
Oh, absolutely. I mean, if you're dealing with giant legal files or complex code bases, being able to feed it the entire problem at once just fundamentally changes the game.
And you could see that advantage in a recent head-to-head against Gemini 2.5 Pro. GPT-5 came out on top in research, coding, even image generation quality.
But Gemini 2.5 Pro still has that top ELO score in the chatbot arena.
It does, around 1466, so humans still really like interacting with it.
So what about the next big step for Google with Gemini 3 Pro? Where are they making their move? Gemini 3 Pro is Google's big push into true native multimodality.
Meaning it's not just text anymore.
Not at all. It handles text, images, audio, and video, all at the same time as input. And they've matched GPT on context, too, with a 1 million token window.
1 million tokens. That's what, like 10 full novels?
About that, yeah. Fed in all at once.
It shifts the goalposts for what's possible with analysis. What about its actual reasoning ability?
The jump there is huge. On a really tough benchmark, humanity's last exam, Gemini 3 Pro scored 37.5%.
And 2.5 was that?
21.6%. So it's a massive improvement. And you can see they're focusing hard on coding. We've seen tests where it generates 3D games and even gives developers in-interface tips to improve their prompts.
Okay, this race for performance is thrilling, but it does bring up a pretty fundamental question about sustainability.
The energy cost.
Exactly. I mean, all this power comes at a massive computational cost. I saw one estimate that said the electricity to power LLMs by 2027 could be astronomical.
Even if that's an exaggeration, it highlights a huge problem. You just can't keep scaling these dense models forever. You hit a wall.
So that forces a pivot to architectural innovation, right?
It has to. And the main answer right now is the rise of sparse mixture of experts, MOE. We're seeing it in models like DeepSeek R1 and Gemini 3 Pro.
Can you explain MOE in simple terms?
Sure. Think of a huge company with thousands of employees. In a traditional, dense AI model, when you ask a question, you're essentially emailing every single employee whether they know the answer or not.
Which is Incredibly inefficient.
Wildly inefficient. With MOE, the system is smarter. It acts like a great receptionist and routes your question only to the small group of specialized subnetworks, the experts, that are actually needed for that specific task.
So it's all about intelligent routing.
Absolutely. The resource savings are massive. For instance, a model like DeepSeek MOE has a huge total parameter count, but it only activates a fraction of them for any given token. You get the power of a giant model for the cost of a small one.
That makes perfect sense. But we're also seeing this trend toward more dynamic control over the AI's thinking process.
Yes, linking efficiency to developer control. Claude 4, for example, has this deeper thinking mode for really complex tasks.
And Quinn 3 has something called a thinking budget.
Right. It lets developers literally trade latency for performance. If you need a quick, good enough answer, you set a low budget. For a critical analysis, you give it a higher budget to let it think longer.
And looking even further down the road, there's neuromorphic computing. That sounds like something straight out of science fiction.
It's the brain-inspired future. The goal is to create AI that uses just 20 watts of power, which is...
Same as the human brain.
Exactly. And the key is moving beyond the deterministic nature of current LLMs.
What do you mean by deterministic?
Well, right now, if a self-driving AI sees a S.P sign printed on a T-shirt, it might just stop. It can't easily distinguish the context.
Ah, I see.
Neuromorphic systems are designed with feedback loops. They're built to check context. I see a P sign, but it's on a T-shirt. The person is walking. I can proceed. It's a much more robust way of processing information.
It's staggering to think about. A computer thousands of times faster than a brain using almost no power.
It's the ambitious goal.
Okay, so let's shift from the proprietary world to the open weight frontier. Because open source is becoming just as critical strategically.
Yeah.
Why is that? Why is openness so important now?
Because open source models, where you get the weights, the architecture, all of it, they offer things that proprietary models just can't. True customization, total privacy, and most importantly, auditability.
Which for a big regulated company is non-negotiable.
It's essential. You need to know why the AI made a decision, and you need to scale it privately without sending your sensitive data to a third-party vendor.
So who are the big contenders in the open weight space that can actually compete on reasoning with, say, a GPT-5 or a Claude?
DeepSeek is a powerhouse. Their R1 model is a massive 671 billion parameter MOE model that is right up there with closed source systems. And their newer V3 model is even surpassing GPT 4.5 on some math and coding tests.
So you don't need a giant cloud provider to get frontier intelligence anymore.
Exactly. And for those who don't have those massive resources,
Right, for smaller teams.
you have models like Quinn 32B. It delivers really competitive performance in a much smaller, more accessible package. Efficient reasoning, as they call it.
And of course, you have the foundational models everyone builds on.
Oh, absolutely. Meta's LLaMA 3.1 is still the leading general-purpose open LLM. But then you have really important projects like AI2's Olmo.
What's their focus?
Total transparency. They release everything. Training data, code, benchmarks. It's vital for anyone working on AI ethics and regulation because you can actually scrutinize the entire process.
And then you have the more niche personality-driven models.
Yeah.
Like Grok 1.
Right, from XAI. It's carved out this unique space focusing on humor and a more casual, rebellious tone, perfect for things like gaming dialogue or creative marketing.
This incredible diversity, both closed and open, leads us right to the big strategic question for businesses. The agentic disruption.
It's the specialist versus generalist debate.
Right. Do you bet on one massive generalist operator bot that does everything?
Like the rumored OpenAI project.
Or do you deploy dozens of smaller, highly tuned specialist agents for specific tasks?
And the expert consensus, especially for high-stakes enterprise work, is leaning very strongly toward specialists.
Why is that? The generalist seems so much more convenient.
It does, but in fields like finance or healthcare, the limited scope of a specialist is a feature, not a bug. They're easier to control, easier to audit, and they provide much higher accuracy because they're deeply integrated into one specific workflow.
Like JP Morgan Chase, using them for fraud detection.
Exactly. The risk of a generalist agent hallucinating or going off script in a high-stakes environment is just too high right now. The specialist provides the precision and auditability you need.
So it seems like we're heading towards a hybrid approach then. It's never one or the other.
That's right. The future isn't a choice between them. The future is orchestration.
Orchestration, like a conductor leading an orchestra.
Precisely. The idea is to use these smaller, specialized models, like the MOE experts we talked about, all working together under a generalized Uber agent that acts as the coordinator.
So you get the best of both worlds.
You do. You get the broad reasoning of the generalist coordinator with the high-precision execution of the specialist agents. It's the only way to get both reliability and broad capability at the same time.
This has been a really comprehensive look at where things stand. So to quickly recap, the proprietary race is all about coding reliability from Claude and massive context from GPT and Gemini.
And architecturally, MOE is making everything vastly more efficient.
While in the open source world, specialization and transparency are key. And for businesses, the strategy is moving toward orchestrated specialist agents.
And if we go back to that long-term vision, back to neuromorphic computing,
Right.
we have to ask a pretty profound question. If we succeed in building an intelligence that's hundreds of thousands of times faster than our own brains,
Yeah.
how can our auditing and regulatory frameworks possibly keep up?
Yeah.
What does it even mean to trust an agent that operates in essentially hypertime, one that makes 1,000 decisions before you can even read its first sentence?
That is the ultimate governance challenge, isn't it?
Yeah.
An excellent and slightly terrifying thought to leave everyone with.
It is.
This discussion was brought to you by TechDaily.ai. You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, contact info@techdaily.ai to get started today.
Thanks for listening.
We encourage you to think about your own LLM strategy. Are you prioritizing context, reliability, or cost? Remember, the best strategy is probably a hybrid one. We'll catch you next time.